Hi, my name is Masheka Lewis, and this is my Thinking Critically solo presentation. A few things before we start. I will be moving my screen you see me in around a lot because I have problems, solutions, and the word is at the top of the PowerPoint. So sometimes I will be moving my screen. Number two, the light. I think this is enough light is for you to see a clear image of me, but the sun is going down and my light bulb is dim, so I had to replace it soon. And number three, I will be pausing my videos here and there. My internet is a little slow, and I realized that if I pause the Zoom recording, that it'll kick back in right away. So to make this not be able to mess up, buffer, or pause me or freeze me in the middle of a question, I'll take little breaks between each question. So it'll give it a little time to kick in. I'll only be taking like 10 to 15 seconds. So, because that's all it needs to like reboot itself, I guess. Gotta love internet. Okay, let's go ahead and start. I need my annotated. There you go. Ooh, got a small one on my here. Okay, so let's start with the first question. Okay, the first question of module 1, part A, is place the digits 8, 10, 11, 12, and 13 in the circles to make the rule of 31. What is the rule of 31? The rule of 31 is having it equal 31 vertically and across. So to do this, we will use guess and check. I believe guess and check is the best solution for this problem because it also helps answer the second part of the problem, which is show all of the combinations of the numbers to prove how many combinations which exist in the row of 31. So with this, we will use first use a counter example because I know the answer. But I will use a counter example to show the solution and how to work it. A counter example is proving that something is wrong, even though basically it's an example of proving something wrong. Help proving something wrong. Okay, with guess and check, you just get any numbers out of the solution. In this case, I'll just choose 10, 11, and 12. So I'll use 10. Oh, that is slanted. 11, and 12. Now, if you add all these together, this will equal 33, which means it does not equal the root of 31. Now, we're going to clear this. Oh, there you go. And I'll show you the right solution. So, with this, you'll have the solution 10, 8, 13, which will equal 31. And then you'll have the remaining two numbers, which is 11 and 12. I did have a note. Sorry, something just got in my eye. I do have a note. A question. What happens if the 8 is not in the middle? As you can see, 10 plus 8 plus 13 is 31, and 11, 8, and 12 is equal to 31. Now, the question is, what happens if 8 is in the middle and 8 is up here? If you put it that way, if you mess up this, the way it is written already, it will still equal 31 this way, but it will equal a different number this way, which means it will not equal to the root 31. And this also brings us to the next question, is showing all possible combination of numbers to prove how many combinations exist in which meet the rule 31. With this being said, this is the only solution that equals 31. Let's go to the next next question. Okay, we're going to have to move this again. I'm going to just move this right. Okay. Now, study the simple diagram and note that 2 plus 8 equals 10, 5 plus 3 equals 8, 2 plus 5 is 7, and 3 plus 8 equals 11. Sorry, I just think it's getting on my nerves. Okay, I think that's better. Against the wall, so it's hard. Okay. In this question, we have to look at the example that is given to us. And when we look at the example, we notice that, like I said in the in the question, 2 plus 8 is 10, 2 plus 5 is 7, 5 plus 3 is 8, and so on. So to solve this, which they want us to solve these diagrams down here, we'll just take the lead of this. So like the solution, we know 2, 8 is 10, equals the number in the middle. So 9 plus whatever this number is will equal 15. So to solve this is simply to add and subtract. So 15, sorry. I don't have a class on today. 15 minus 9 is 6. 20 minus 6 is 14. 13 minus 14 is 3. And we can check, saying 9 plus 3 is 12. 9 plus 6 is 15, and so on and so on. So this equals out. Gotta move this now. Okay, we'll just do the same thing as we did in the previous one. So 13 minus 6 is 7. 11 minus 7 is 4. 19 minus 4 is 15. And again, check. With checking, we know that this also check out. It's very important to check because sometimes the solution might not add up like the one I'm about to show you. So we have 8 and 3. So 8 minus 3 is supposed to be 5. 15 minus 5 is 10. 12 minus 10 is 2. It is very important that we check our, something like is terrible. It is very important that we check because we'll notice that 2 and 3 does not equal 6, which means this is undefined. So let's continue to the last one. We have 8 and 18. Oh, this is something. 8, 18. So that equals 10. 15 minus 10 is 6. 7 minus 6 is 1. Again, check, and we know that it equals. Now I have another question. Let's clear this. For the question is, can you use algebra to solve this question, even though it is easy to solve with adding and subtracting? Now, to answer the question is yes, you can use algebra. You can use algebraic expression, which is using variables and numbers to find a solution, or using your solution to find a missing variable. So let's use the last one, 18 and 8. Let's say we're looking for this blank circle. So instead we'll use an x. So we're looking for x. So to solve this, we'll use subtract 8 from both sides of the equation, and that'll leave us with x equals 10 because 18 minus 8 is equal to 10. And that's how you'll be able to solve the problem. Let's go to the next problem. Perimeter. Okay. I'm gonna pause this for a little bit to make sure I don't get this, so this does not skip. Okay. For this question, it says you'll have 9 square tiles laid out on a table so they can make solid pattern. Each tile must touch at least one other tile along the entire edge. See the 2 examples on the right. This is how you're supposed to stack your. This is an example on how you're supposed to stack the tiles or move the tiles. They have to be completed on the edge for square. The square of all sides are the length of 1. Okay, so this is a 2-part question as well. So part A is sketch all possible figures which can be found and calculate the perimeter. Part B is find the perimeter. When you find the perimeter, figure out which one is the least perimeter and the greatest perimeter. Okay, let's go to the next page. In this problem, you'll have to make various shapes of 9, and basically to solve this problem, you'll have to know how to solve for perimeter. Okay. Now, this is just the question written again on another slide. Now, I know it says sketch all possible shapes that can be formed, but I don't want you to get put through that trauma of me sketching, definitely with the computer. So with this, I already have it built into my slide of the shapes, making sure each have 9. I forgot to put that one there, so it moves to that one. So to calculate perimeter, you have to add each side, and then when you add all the sides, the total is your perimeter. So this is 3, 1, 2, 3, 1, 2, 3. So this is 3, 3, and 3. So you'll add 3 plus 3 plus 3 plus 3. And this will equal 12. Now I was just showing you how you're supposed to get the perimeter. I'm going to clear the drawing because I have the perimeter as well. So you don't have to see all the scratches around the screen. Now, we'll just continue like we did with this one, which is 4, 1, 4. Then we have one side 1, 1, 1, 5, and 2. And the perimeter will equal 14. Again, 3, 1, 3, 6, 2, 15, and so on, so on, so on, of the other 2. This will equal 18. And this will equal 20. As for the next problem, which is on the next page, part B, let me go back real quick. So we know the perimeter are 12, 14, 15, 18, and 20. These are the perimeters. So that equals, that's the answer to the first part of the question. I also have another spark note for this one. Is if there's a way you can find the perimeter using multiplication. The answer to that is yes, you're able to find the perimeter of multiplication, but there's only certain ways, certain objects, I guess you'll say, you'll be able to find the perimeter. Like this one, the 3 by 3 by 3, this is the easiest way to explain it. This is one of the examples you can use it. You're not able to use the perimeter on this one because it has different sides and other sides. And you'll understand why I say this in a minute. So like I said, this is 3, 3, 3, 3. As you notice, they're all equal to 3, and there's 4 sides. So to find the perimeter to this shape, you'll do 3 times the number of sides is 4, and you equal that 12. And that is also the perimeter. Now you're not able to do the same thing on a shape that does not have the same equal size or same equal sides or number of sides. 2, 3, 4, 1, 1, 1, 5, and 2. If you multiply 4 plus times 1 times 1 times 1 times 5 times 2, that will equal 40. And 40 and 14 is totally different from the perimeter. So you'll end up getting the area instead of the perimeter if you do it with a shape that does not have the same side number. Okay, let's go to the next one. Oops. Okay. The next one is which is the greatest and least which had the least and greatest perimeter. Oops, go back. Again, I have the shapes. Oh, go back. Now, as we remember, this is 12, 14, 15, even though it's missing a square, 18, and 20. So if we calculate which is the greatest and which one the least, 12 will be the least and 20 will be the greatest perimeter. Now let's clear and go to the next. Okay, let me stop this real quick. Okay, so this question is, kind of move this real quick, is consider a new sequence of dots considering below, which is this, and complete A through C. A, draw the next two figures to continue the sequence of the dots. B, list the sequence of numbers correspond with the sequence of these. C, add 4 more equations, which are these are the equations that they're talking about. Add 4 more equations from side parts A and B. So you'll be using A and B to help solve for C. D, observe each pentagonal number is the sum of an arithmetic progression. Compute the 10th term in the arithmetic I always get tongue tied over it. I know what I'm supposed to say, but it just won't come out. Arithmetic progression 1, 4, 7, 10. E, show the formula for a pentagonal number and calculate the 9th, 10th, and the nth term. Okay. Let that word back to me. Okay. Ooh. Too far. Okay, to solve this problem, since this was on the other side, to solve this problem, you'll need to look for patterns. Patterns will really help you solve the problems and give you the correct answer that you're looking for. So let's just go ahead to the next problem. Okay, A, draw the next two figures to continue the sequence of the dots pattern. Okay, so to draw this, we'll have to look at our example right here. Let's get my drawing tool. So we'll need to look for a pattern. So we go to 4. This is plus 7. And this is plus 10. Now, to look for looking for pattern strategy is, oh, I do not remember what I just wrote, is, oh, okay, so looking for a pattern is to look at the sums that it's giving, which is these, and then find a pattern to help solve for the other, to help solve for the rest of your answer. That's been kind of simplified from the textbook. Okay, so if we look at these, we'll notice that 1, 5, 12, and 22. Now, at first, you won't think there's a pattern until you look at the numbers 1, 5. If you look at number 1 and 5, you'll notice that 1, you have to add 4 to get 5. And then when you look at 5, you have to add 7 to get 12. 12, add 10 to get 22. Now, if you look at 4, 7, and 10, you'll notice that the pattern is adding 3. So we stopped at 10. We're looking for the next 2. That's pattern, so let's add 2. So 10 plus 3 will be 13. 13 plus 3, which would be 16. Now, with that in mind, we know that this number that it previously was, add by the number it's going by, which is 10. 12 plus 10 is 22, which means 22 plus 13 will be the next pattern with dots in it. So we have 22 plus 13, and that will give us b equal to 31. Now, if we had the dots of 31, we'll have 31 plus the next term in our sequence, which is 16, and this will equal 51. So if we look for a pattern in our diagram, we notice that it'll go from 22 to 31 and 31 to 51, and that's how many dots need to be in our next 2 patterns. Now, I have a question from the Spark Note is, how do you know where the dots in the sequence will go? Well, for that question, you'll have to look at the diagram itself. We see 1, and then we go 1 to 5. Now, if we look at how the dots placed, it's actually easier to see with 5 and 12. We'll notice that it'll add 2 and add 2 because it adds 4. It adds 4 dots. So it add 2 to the side, add 2, going diagonally this way, and going diagonally to the left this way. Now, if we go 5 to 12, we know that it goes 3 up this way, 3 up this way, 3 up this way. Now, to number 22, we know it goes 4 up this way, 4 up this way, and 4 up down this way. Now, if we're just looking at the pattern, we'll note that it'll have 5 dots in our next pattern going this way. 5 dots going this way, and then 5 dots going this way. So that's how you'll know where to place the dots. Let's clear this because that was terrible. So we'll go this way. So remember, we had to have 31 dots in our next sequence. So we'll place 31, and where to place the dots is looking at our last pattern. So this has 4, so this should be having 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the correct pattern, and make sure it has 31. Again, you do the same thing, but this will have 6 going up, 6 going up, 6 going down. And that's how you'll find the 2 patterns and how to draw the next 2 dots in a sequence. Now, part B of the question. List the sequence of the number that correspond with the part A. So what did we just find in part A? We found that this is 1. Oh, go back. Wow. that did not go back. There we go. Sorry about that. I'm having trouble navigating my Zoom annotated. So, when we do list of sequence, these are the numbers that we just found. So how we found this is, again, this is 4. Again, this is 7. 12 to 22 is plus 10. So if we notice that this is adding, move that there. This is adding 3. This is adding 3, which means our next two will add 3. So 10 plus 3 is 13. And then 13 plus 3 is 16. And then we'll have to add this with the number that previously was. So 22 plus 13 will equal to 35. 35 plus 16 will equal to 51. And these are our missing correspondence that we just had, that we just found. So go 1, 5, 12, 22, 35, 51. And let's check our answer. And there we go. Let's go to the next. Add 4 more equations to the list on the right, well, to the left, and subjected by A through C. So you won't have to see me struggling writing the 1, 4, 7 again. I already had this listed, so we won't have to struggle to do that again. Okay, then I have a question. Okay, no more questions for a little bit. Okay, so as you can see, it goes 1 equals 1, 1 plus 4 equals 5, 1 plus 4 plus 7 equals 12, 1 plus 4 plus 7 plus 10 equals 22. And if we notice, we'll see that the number that they're adding is right here, is our term that they're adding. Sorry, I need to stop for a little bit because I was going on a little bit. Okay, so to solve this, you'll use deductive reasoning. Deductive reasoning will be the best place to use this at, because deductive reasoning is making a statement true by looking at previous statements to prove that our next statements or our answers would be correct. So what I'm saying is that, let's get back to red. Sorry, you're gonna have to see this for a little bit. 1 plus 4 plus 7 plus 10, and our next is 13 plus 13. Now, how did I know to add 13? This is using deductive reasoning because we use from our question, or the previous statements given to us, we see that they're adding each term every time. So using this, we know that our next equation will add another term, which will be 13. This will equal 31. And as we continue, 1 plus 4 plus 7 plus 10 plus 13 plus 16 will equal 51. And like I said, use deductive reasoning. How we know that to add 15, because our previous statement was proving that they just add another term every another equation they was doing. So again, we have to, let's do 3. 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus our next term, which is 19, will equal, not yet. This will equal 70. then our last equation to write is 1 plus 4 plus 7 plus 10 plus 13, 15, 19 plus 22, and this will equal 92. Now, so you don't have to try and squint your eyes to try and read that, I have already put this as part of, so you'll be able to see it better instead of reading my red scratches for my computer. Okay, so this is how you'll use deductive reasoning to find the equation, rest of the equation, rest of the four equations. Now, let's go to D, which is observe that each, I think that this is getting terrible again. Observe that, there we go, each pentagonal number is the sum of an arithmetic progression. Compute the 10th term and the arithmetic progression 1, 4, 7, 10. Now, if we continue how we use, go back, this, I can't use that one, annotated. So this we can just use from our previous answer. We know that this is adding 3, and so on. So we know this will be 13 because 3 added to 10. We have 16, 19, 22, 25, and 28. Now, let's go to the next problem. Okay. Will that be? Okay, yes, what? Okay. E. Show the formula for pentagonal numbers and calculate the 9th, 10th, and the nth term. Okay, for this, you'll use Gaia's Insight. And Gaia's Insight, okay, I thought I had a question, but I didn't. Okay. Guess it's time for the next one. Okay, Gaia's Insight is having, to simplify it, it is computing the terms that we already know of, 4, 7, adding them, and then finally reversing it, which will be whatever term it goes in. So if we're looking for a 9th, if we're looking for a 10th, if we're looking for a nth, we'll use that. I already have this, so you won't have to see me doing that since it's terrible. So let's just compute the 9th. Okay, so S or is what you usually use, but I usually write it out. So this equals, we're trying to find the 9th, so we'll put 9th in the parentheses and then look for the 9th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 25. So this will go all the way to 25. And then using the Gaia's Insight, we'll start from 25, go down until we have 7 plus 4 plus 1, and so on. The first two numbers is the only one that matters. So this is 25 plus 1 is 26. So 26 would be the one that goes here. So 9 times 26, and then we'll divide this by 2, and whatever the answer is will be the number, will be the 9th term. Will be the 9th pentagonal number. And this will be 117. Now, using the same thing, this is, it's really, I can't use it. Maybe that'll work. I don't know. I think it just freezing up again. I guess that's because I haven't paused it in a little bit. So let's clear this and let's compute the 10th. Again, same process. I'm going to write 10. Usually the equation is S, but I would usually write 10. So we're looking for the 10th. We go to the 10th, which is 28 this time. So 1 plus 4 plus 7, so on, so on, so on. 28 plus so on, so on. 4 plus 1. And we have 29. That was being 8. The first two is the one that really matter. So 28. We'll multiply this and then divide this by 2. And this is 145. And 145 is our 10th particular number that goes. I keep going down here. I'm sorry. Let's erase this. Now let's calculate the nth term. The nth term is different because it don't have a number that we're looking for. So this is just random. I keep looking for questions that I don't have. Okay, we'll use guess insight for this. So for the nth term, we have, to look for this, we have the equation of 2t equals n, let's erase this. We have an equals a1 plus b. I'm sorry, I got ahead of myself. That's actually the last one. B, and then we have n minus 1. To calculate this, we replace our numbers. A1 will be the first term, which is 1. D will equal the distance, which we know is plus 3. So plus 3. And then drop the n minus 1 down. So we have 1 plus 3 n minus 1. Then we distribute, which will be 3n minus 3, and then plus 1. Then we combine like term, which is negative 3 plus 1 is negative 2. And then drop down a 3n. And this is our nth term. Now let's clear this. Is this on? Please tell me it's on this whole time. Okay. So I have this in case you can read my, in case you can read Blackish wrote. This is the guys insight. And the nth term. So 1a, a1 is our first term, which is 1. D equals the distance, 3, and then n minus 1. So let's go ahead and go to the next problem. I'm going to finally pause this so I have time to load. Okay, hopefully that works better. Okay, this is complete the addition of pyramid. To solve this, you will be using equation expressions to help solve the rest of the pyramids, that the missing letters and links of the pyramid. So let's go to the first one. We can just look at the example. In our example, we notice that 3 and 5, okay, yeah. 3 plus 5 is 8, 5 plus 4 is 9, 5 plus 9 is 17. 8 plus 9 is 17. I need glasses, my glasses. I don't know where they're at. Okay, let's go ahead and compute the first one. Now, we have, to do this, we need to solve it with the expression. So, we're looking for the blank, and we can go ahead and compute this, which is 5. We can compute the blank, which is x plus 2. So we'll just put x plus 2 in parentheses, plus 3 to find, to equal out our top number. Now let's see if we're looking for our, this is the edge that we're looking for, not this one, but this is the bottom. We already have half of this row. So to find the missing number, we just compute the bottom row and then the top row. Just find this, which is what I just wrote. So now 25, we combine like terms. So this is x plus 5 after combined it. And then this is equal to 25. To solve this equation, you subtract 5 from each side of the equation. Okay, now my mouse is acting up. So then you have x equals 20. So this x that we're looking for, not this one will equal to 20. And to find our missing x that we were looking for in the first place, we can subtract 20 minus 2, which is 18. So we can, let's clear this. This will be 18, this will be 20, and this will be 5. I do have a question, finally, that I got to my other one. Our last question is, are we able to complete this pyramid without using expression? The answer to this question is yes, you can complete this without using the equation expression. So to do this, you can just say 3 plus 2 is 5. We have 25, so 25 minus 5 is 20. And then 20 minus 2 is 18. This is working backwards. Working backwards is having a solution but don't know where you start. But in this case, you know where you start. You just work backwards to get to where you're trying to go, which is the start of the equation and the start of the problem. And the bottom row is the start of the problem. So it is working backwards to find the solution that we're missing. Let's go to the next one. Oh yeah, so you want, so in case you didn't understand what I just, okay, let's back it up again. So you can understand what I just did. A plus 2 plus 3 equals 25 to find the middle row. Combine like term, x plus 5, 25, subtract the 5, equal to x that's right here. And then that will equal to 20. And then subtract 2. Now, the second one. You can't find any of the middle rows. So you'll have to just find the bottom row instead. Let's get this. Thank you. Okay, to find this, you'll have to make an expression, equation expression, or algebraic expression for this. So 1 plus y plus y. And we know that all three of these added, or these two added make this, and these two added make this. So we'll just add this to get the second row. And then y plus back to 2. And then we're going to equal that to 18 since that is our final product. So then we combine like terms. So we'll have 2y, and then 2 plus 1 is 3. So plus 3 equals 18. Now subtract 3 from each side of the equation, since 3 is by itself. And we're trying to get y alone. So this is 15 equal to y. So that be back to 15. Okay, it's messing up again. Okay, as I was pausing it for the 15 seconds, I noticed that I need my glasses very badly. So instead of this being 18, it's actually 15. So I'm going to erase this, everything I just did. Okay, it'd be easier if I just clear this. And we're going to do this again. I wish you wouldn't edit some videos, but it seems like we can't. So, sorry about that. Okay. So, we're going to continue like we did, which is 1 plus y plus y plus 2 equals 15. I renewed my glasses, but I broke them, so I had to wait like a good 2 to 3 days before I get them. So again, combine like terms, which is 3 plus 2y equals 15. So then uh, we subtract 3, subtract 3. This is 2y equals 12. Subtract 2, subtract 2 is y equals 6. Now we plug in 6 for y. So 6, so 6 plus 1 is 7. 6 plus 2 is 8. And 8 plus 7 is 15. Oh, I gotta wait for the glasses. I'm sorry. But at least I corrected it. I'm so sorry about that. Now let's go on to the next problem. Hopefully I'll be able to see this one. Again, it shows right there in case you couldn't read what I just did. So combine the y's, which is 2y, combine the 1 and 2, which is 3, and then equals 15. Then we'll subtract the 3 from 15, which would make it 12, and then divide the 12 by 2 to get the y amount. Okay, let's have the last one of these figures that we need to solve. Okay, this, we don't have no variable in the bottom row. So we have to find z in the, oh, go back. Thank you. Go find the z in the second row. Now, to solve this, you will have to find the distance between the 2 and 6. And this is plus 4. So we're looking for z, so we have z plus z, okay, 4 plus z. I'm going to just put it like that. I usually put z plus 4, so we're going to do it this way instead. It then equals that to 27. So again, combine like terms, you'll have 4 plus 2z equals 27. Then you'll subtract the 4 from both sides. So that makes that. Is that a question? I thought it was a question. No. Okay. Let's make that. So then we have, if I can make this right, 23. Got it. So then we divide this by 2. Gotta move that. So divide this by 2. Divide this by 2. And then this will be 11.5 equals C. So we put 11.5. So to get our missing bottom row, we just subtract 11.5 minus 2, and we equals 9.5. Gotta love internet. Okay, this is 9.5. It's then 9.5 plus 6. That will be, this is, if there's a question, no. 15.5. And that's how you solve this one. Let's clear this so you'll have a way better problem. Again, combine. Ooh. You gotta love my computer. Okay. So we'll combine like terms up here. And then right here is combining like terms. I'm going to actually show you on this one. Subtract 4, 23. What was that? Okay, 23 equals 2z divided by 2 divided by 2 equals 11.5. And z is equal to 11.5. And again, this is 11.5. Subtract by 2, 9.5. And this will equal 15.5. And that will equal 27. D2 equals 27. Is that clear? Because I think I am past the 20 mark at the moment. And I have 2 more left. No. Okay. Hey, it worked. This question, or question 5. Four married couple belong to a cup. I didn't even touch anything. Okay, I didn't even touch anything. I'm going to pause this real quick. Okay. I think that just fixed it. And then solve it. So there's 4 married couple belong to a club. Katie, Sarah, Josie, and Ann. And then for males, David, Will, Floyd, Gus. And this problem, we have to find who's married to who. So for this, I'll use process of elimination. Process of elimination is eliminating the one that you already know that is not married to them. So you'll know, or doing a solution in general, without the question, is eliminating a solution that we know that is not equivalent to the problem. So let's do stamp and check. So we will start by Josie is Floyd. Floyd is Josie's brother. So we'll already know that Josie and Floyd is not married, so we'll put an X. Gotta move this. Okay, and it says Josie and Gus dated some, but Gus met his wife. So we know Josie and Gus is not married, so go to Josie, down to Gus. So we know that is not Gus. And then Katie is married to Will. Kitty is married to Will. So Katie and Will, we do know they're married, which means that he cannot be married to all the other girls. And with that, we know that Josie is married to David because he is the last one on her row. And Kitty is married to Will because it gave it to us. So we use process elimination to eliminate all the other choices by what they gave us. And then it had our solution left, our real solution is left. We're also supposed to check our solution to make sure that it's checked out, but we had to finish our rest of our chart to make sure. Okay, it says N has 2 brothers. That does not help at the moment. And N husband is an only child. Okay, with N is only N husband is an only child, we know that Floyd and Josie is brother and sister. So Floyd and Josie is brother and sister, which means Ann cannot be married to him because he is a single child. And then we can exit out, exit out Floyd. So with Floyd exit out, that means our only solution is Ann and Gus. I forgot to put the X here. So let's X out all of the rest of these. And with everybody exit out and everybody already married, that means that Sarah will have to be married to Floyd because he is the last one standing, basically. So let's finish putting X's. So make sure that even when you use process elimination, make sure that it equals out. So Joycey married to Dave, Katie married to Will, Sarah equals married to Floyd, and Ann is married to Dad. No husbands overlap, which means that we did our problem right. And it seems that I have to keep doing this even more because it's not helping anymore. So we're going to try to do the last question fast. So question 5 is answered. Use the process of elimination to eliminate who and was not married. So our last question, let's go here. Oh, I have this. I use heart and cross out signs to see if they're married or not. If we, and this is a check, and this is the answer. And seemed like everybody got married to who they were supposed to, and we used the process of elimination right. Let's pause this before we go to the next one. Okay. Okay. Is that considered their transposal numbers? It gives us the numbers. It's an A, create a dot pattern represented of the transposal number. B, knows that numbers is 1 times 3, 2 times 4, 3 times 5. Show how you can represent the transposal number into a rectangle. And C, using inductive reasoning, show how what general formula gives the nth transposal number. Okay, let's go. I'm sorry, I'm trying to rush this. Okay, so we know what we know it's supposed to look like this because that is what a trapezoid is, and that's what it meant by transposal number. So we had to have a shape looking like this. Now it says to create it. We're going to move this down here then. So if to create this, let's have 1, 2, 3. So let's have a space of 3. Let's have circle instead. 3. So we're going to try and create this. How I'll do this is we looking for a transposal number. I mean, a trapezoid shape basically. So let's have this line right there. Okay, so we know how a trapezoid shape is. Let me draw it again. So the top smaller than the bottom basically. So with this in mind, we have 1, 2, 2, 2, 1. So when I see this, I'll think of it as a step instead of just adding. So we count the bases, which is 1, 2, 3, 4, 5. So our bases will be 5. So let's do 5 circles. 3, 4, 5. Okay, I know that's terrible. And then 2, 2, 2, which means we're going to have 3 at the top. And this does look like the shape somewhat, this terrible shape. And then another. So that says, it just says nth, and then it don't have a number. So that just make up for the 3rd and 4th row. So we'll have 1, 2, 3, 4. Oh, we still have this one to do. 1, 2, 3, 4, 5, 6, 7. So 7, 1, 2, 3, 4, 5, 6, 7. Let's move this up. And then we go to 2, so we step up to the 2. 2, 3, 4, 5. And then we'll have the trapezoid shape, sorry. And then we have 3, 3, 3 at the top. So 1, 2, 3. I know that looks like a square. I mean a triangle, but I'm just very terrible at drawing. with this. That's supposed to be that shape. So we have this. And if we continue, it'll just do the same thing. Like if we have 4 rows, which is, I'm going to just clear this. If we have 4 rows, we'll just keep adding 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, because we're adding 2 each time. And then we step up from 2. Every section just steps up 1. It just subtract 2. So 9. If this is 9, this will be 7. This will be 5. And this will be 3. And this is how the fourth one will look. Let's go to the next one. The next, this is our example. I thought I had a question. No, I don't. Okay, I think I don't have any more questions left. Okay, I think I already hit the 5 anyway. Okay, the second question is they want us to make the trapezoid shape, basically, into a rectangle shape. And it gives us, where's my annotated? Sorry. It gives us how they want us to do it. They want us to have more columns than rows. It's right here, 3 plus 5. So first we need to figure out what is row and which is column. Rows go sideways, columns go up and down. So we need more columns than rows. So how will we be able to know which shape to put this in? We'll just make sure that the columns have more than a row. So 1, 2, 3, 1 row and 3 columns. Okay, we're gonna skip to like a little distance. And then 2 and 4, we have to have more columns than rows. So if anything, that means 2 rows and 4 columns. Okay, our third one is 3 to 5, so we need more columns than rows, so the 5 equals the columns. So 3 rows and 5 columns. And that's how it's supposed to look. Does that clear this? Oops. There we go. And it's supposed to look like that. C. Use inductive reasoning. Show what general formula gives the nth trapezoid number. Inductive reasoning is to use a general conclusion and a general conclusion from the other statement that was made. So we'll know if it's right or not. I need to have this up more. Okay. Looks like my head's down. Okay. Use inductive reasoning, which is inductive reasoning is we know where we're starting at, and it's just a general question, so we don't have an actual true answer. Now, if we look at our other two, if we look at our other 2 examples, we notice that in our trapezoid, each level is subtracted to, and in the rectangle, it added to. So I have a feeling that 2 is a major role in this. So we'll use n, and then we'll have plus 2, because we're looking for the 9th trapezoid number. And this is the guess. So we'll use N to fill in the blank. So using a trapezoid number, and it has add 2 minus 2. So, okay, my finger's really acting up. So, let me see. As we look at this, let's clear this. As we look at this, we can see that it is adding 2 as it keeps adding. So we'll have plus 2. And then we'll use the N formula for the guys inside. And that will be N. So this will be your answer. And my thing is acting up, so I guess that's it. Hopefully my glasses and lighting and internet will all be fixed next time. But as for now, I'm sorry. So let's, okay. I thought it says play, resume. Is that I did not record that. Okay. As for now, that's it.